Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
I'm Darshan.
I'm Kelsey. For math homework help, call in Bakersfield 636-4357. Everyone else 1-866-636-6284.
Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done. So, Darshan, where do you go to school and what grade are you in?
I go to school at Stockdale Elementary and I'm in 6th grade.
6th grade going well?
Yeah.
Have you been to Camp Keep yet or are you going to?
I've been to Camp Keep.
And how was that?
It was a fun adventure.
Oh, good. So you were able to stay there the whole week? Because I know some schools go for part of the week or a day.
I know, I remember my teacher told me last year, and they only went on Tuesday because it was raining.
Oh, wow. So you got lucky this year then?
Yeah.
All right, good. So, Kelsey, where do you go to school and what grade are you in?
I go to school at Del Rio Elementary and I'm in 5th grade.
And what is the best thing about 5th grade so far this year?
Being able to do so many activities I couldn't when I was in the primary grades.
What's one of those activities maybe that you like doing?
Oral language.
So, did the Oral Language Festival, did you just do that at your school? Is it coming up?
Well, this Thursday is the regional competition.
Okay.
So, yeah.
Are you in the regional competition?
Yeah.
Well, check you out. You moved on then from your school, right?
From district.
Oh, so you won at your school, right? Because you have to win at your school to go on to your district, right?
Yeah.
And then you obviously won at your district, and now you're going on to the next one.
Yeah.
And what is your category?
Serious duo.
Serious duo. So you and the person you're doing this with have done this for a long time, right? Because doing a duo, you got to work together pretty tightly and especially to move on like that. So congratulations.
Thank you.
I was going to say good luck on the school competition, but you nailed that. And
No,
then you're like,
necessary.
hey, old man, I took the district 1 and 2 and took that away too. So nicely done.
Thank you.
Now you were recently in a competition also, right? But not oral language. You were in a math competition, right?
Yes.
And what was that?
Math counts.
Now isn't that for 7th and 8th graders?
Yes.
But some 6th graders too, right?
Yes.
So you're competing against 6th, 7th, and 8th graders.
Yes.
And how did you like that competition?
It was fun. It was challenging.
Well, I'm sure that's what it was meant to be as far as, you doing that, right? Because if you do that as a 6th grader, you'll be that much more prepared as a 7th and 8th grader if you continue doing that competition, right?
Yeah.
Good. So you learned a little something while you were doing that, right?
Yeah.
All right, good. And you like the oral language thing, huh?
Oh, yeah.
All right, good. Well, I'm going to need both of you to work together right now because you both need to help me solve today's social media problem today. You ready? All right, let's take a look at it together. Darshan, go ahead and read that for us up there.
Which expression can be used to find the volume of the figure?
All right. So, Kelsey, when you look at that problem and it says which expression can be used, what do you wonder about? What do you know already? Is there anything you know or are there just things you're wondering about?
I have a pretty good idea about the area, the length, the width, the volume. So it can.
Yeah. So tell us what you know. So you're talking about.
Well, I know that the volume can be found because it says 3 centimeters, 7 centimeters, and 8 centimeters for this the rectangle on the right side. So I can find the volume using those numbers.
So volume, you just simply multiply 3 numbers together, right? Height, width, and length. You could do that, right?
Those 3 dimensions, right? For a 3-dimensional
Right.
shape to find volume?
Right.
Okay.
So let's take a look. Do you want to do the one on the left-hand side that's horizontal, or you want to do the one on the right-hand side that is vertical?
The one on the right-hand side.
So what numbers do you think we would need to multiply to do that one?
The 3, 7, and the 8.
The 3, 7, and the 8. Good. Okay. So let's first of all take a look up there and see if we have 3 times 7 times 8 anywhere in any of those answers.
It's B.
In B, all right. So Darshan, if we take a look at the other piece of that, what three numbers would we multiply to get that one?
We need 3, 7, and it looks like also 8 because it's 5 and 8, 3.
Okay.
You're adding the
So we're-
total length of both of those
Yeah.
rectangles
I
together.
get it. So it's just 3 times 5 times 7 because we already did that one.
Okay, because we already included the 3, right?
Yeah.
So you want to go 3, 5, and 7?
Yeah.
So we need a 3, 5, and 7, and we need a 3, 7, and 8, right, in order to multiply this correctly, right? So out of all of those, because up on top we have a 3, 7, and 5, and we have a 3, 5, 8, is that going to work?
No.
No.
All right, you both agree on that? No. All right, what about B? 3, 7, and 5, we need that, and we need a 3, 7, 8.
Yes.
Yeah.
All right, let's take a look at the other ones before we just stop on B. 3, 7, and 5, we know that's good, right?
Yeah.
Now what about 3 by 3 by 8?
No.
No.
You sure?
Well, no, I'm not sure. So.
Well, that's fine if you. I'm not trying to trick you. I just want to
mean-
make sure that you're good with what you're
in
saying.
the other one, it looks like there's only 1, 3, other than the ones that are like.
Right, and the bottom one doesn't even have 3 different dimensions,
Yeah.
right? It's just got a 3 by 8. So out of all of those, which one do you think is correct?
B.
B.
You both agree on that?
Yes.
All right, let's indeed see if B is indeed the correct answer. And there we go, B is correct. There you go, first problem all done. See how easy that was? All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to do with today. Exactly today, it is Mardi Gras, Fat Tuesday. So there are a lot of people out there that understand Mardi Gras is Fat Tuesday, and it's when people indulge a little more to get ready for fasting. So Mardi Gras, otherwise known as Fat Tuesday, is the final day of Carnival, in which people celebrate by eating a lot in preparation for fasting. Some traditions include parades, balls hosted by crews, different societies. There are 3 main colors associated with Mardi Gras. Green, which represents faith, purple for justice, and gold for power. Those are the 3 main colors that you will normally see associated with Mardi Gras. So Mardi Gras throws are strings of beads, and I just found out there are a new set of beads that have come out, and they're biodegradable because most of the beads are plastic. And the beads are now biodegradable and they have seeds inside of them. So when they get washed away, like many of them do, these things will be able to degrade and then have seeds inside of them. So there's purposes for these new beads. Anyway, so Mardi Gras generates billions of dollars. This is a big, big, big thing going on, especially for New Orleans and other cities around the country. A lot of tourism, there are a lot of people going to New Orleans to celebrate Mardi Gras. Mardi Gras had an economic impact of $189 million in New Orleans, which is 3% of the city's gross domestic product. So they had a return of $2.64 for every dollar spent. So if they get that kind of a return, they will spend money to bring people to New Orleans to satisfy themselves celebrating Mardi Gras. So they'll go, fine, we're going to spend $1 on having you come down here because we're going to get back $2.64. So there's an automatic profit in that right there. So gross domestic product. You take the consumption plus the investment plus the government spending plus net exports. Then you're going to take away the imports. So we can see that down here, we will figure out we spend $10 million. So that is our consumption. We invested $2 million. The government spends $3 million. We export $1 million. We import. So if we export something and import it, it's not going to be the same mathematical thing because when you're adding, when you're subtracting. So we import $500,000 So we're going to subtract that. So if we have the 10 and 2 is 12, 15 and 16, minus, we have 15.5, and I believe this is all million, big amount of dollars. And that is today's Math in the News. We'll be back with more right after this.
Hi, my name is Augustia, and my Chalk Talk topic is Vedic Maths. Vedic Maths is a fast and easy way to solve everyday math problems. The founder of Vedic Maths was Sri Dharaji from India. The word Vedic comes from Vedas, which means fountainhead of all knowledge. Now let me present you some tricks of Vedic Maths. The first trick is multiplying any number by 11. So imagine I have the number 1,892. And I have to multiply it by 11. So what I'll do is write 1,892 and add 0 on both sides. So I add 0 plus 2, which is 2. 2 plus 9, which is 11, carry the 1, then 9 plus 8 is 17, plus 1 is 18, and then carry the 1, 8 plus 1 is 9, plus 1 is 10, write the 0, carry the 1 again, then 1 plus 0 is 1, and then add the 1, which is 2, and that's your answer for multiplication of 11 formula. My second trick is vertically and crosswise multiplication. So imagine the numbers 83 times 24. First you multiply 4 times 3, which is 12. Write the 2, add the 1. So 2 times 3 is 6, and 4 times 8 is 32. You add all of them up and you get 39. Write the 9, carry the 3. 2 times 8 is 16, plus 3 is 19. So your answer is 1,992. My next trick is addition dropping 10 method. This trick is used for like adding big numbers, like 2,000. So first you add 2 plus 3, which is 5, and then add 5 to 7, which is 12. And you underline the 1 because it's going over 10 to make the problem simpler. So you write this for like a carry, and then you write the 2 down here. So this line counts as 1. So 1 plus 6 is 7, plus 1 is 11. So carry the 1, then there's 1 again, 1 plus 8, 9. So 9 plus 5, 14, plus 4 plus 1 is 5, plus 6 is 11. 2 plus 8, 10. So 0 plus 1, 1 plus 9, 10 again, plus 0 plus 1 is 1, and 1 plus 1 is 2. So that's your answer for dropping 10 method.
And nicely done. Let's talk math right there. And that's a classmate of yours, isn't it?
Yeah.
Did you follow along with what he was doing?
Actually, not classmate.
Oh,
Schoolmate.
he goes to the same school with you?
Yeah.
All right, there you go. All right, so you guys are familiar with each other?
Yes.
All right. So we're going to do something right now, because usually Devin works with one of the students and has them go through a couple of different math problems. But you two are the lucky ones today, because you're going to be both of my tutors today. Sound good? So you're going to be the tutor for this problem right now. All right? So head on over to the board, both of you guys. Devin, if you would please write this equation up on the board. 2x plus 7
2x plus 7.
equals x plus 3. All right. So,
There we are.
Devin, I would like you to show and explain to Kelsey how to do an equation because you've never done one, have you?
No.
All right, here we go. Take it away.
So go ahead, Darshan.
Okay, so first, one thing you need to know is that you need to isolate actually not one, couple. Before you can find it, you need to somehow isolate the variable to one side. You also need to balance what you do. So if you do something on this side, you need to do the same thing on this side.
So the main question we're really looking to answer is, what does x equal? Do we know what x equals right now?
As of now, no.
No. So what we're looking to find is the value of x that makes this statement true when we plug it in after we find out what it is.
Okay, so do you know so here we can subtract x from here. I'm just doing it how I do it. So that because if I just do any other way, it's still going to be there. So then I would subtract x from there, the same thing on both sides, just once we'll draw a line. So since it's 2x minus 1, 1x, it's going to be 1x. You understand? Mm-hmm. Plus 7 equals 3, because it's plus 3. It's just positive 3.
So you took 1x away from 1x, and even though we don't know what x is, we know that something minus itself is always going to equal 0. So this is essentially 0 plus 3, but we don't need that 0, so that's why we're leaving it just as 3.
And this 1x is equal to x itself. So here, since x is here, we need to remove everything touching the x. Well, this we don't need to do anything because that would just equal x. Here, you can subtract 7 because you're adding 7. Same thing here. X equals, do you know how to subtract negative and positive?
We haven't covered it, but I'm pretty sure I could figure it out.
So 3 minus 7 would be negative 4.
Now, are we clear on why that would equal negative 4? Yeah. Okay. So we don't have to go too far into how to get to
So x equals negative 4.
Now, there's a really important piece here. We found what the value of x is. How do we find out whether that actually works to make that original equation true? What can we do with this information, x equals negative 4?
You plug it in.
So let's go ahead and do that. So
maybe instead of writing it up top, maybe where they're at as far as their height, they can just rewrite it down below the x equals negative 4.
So let's go ahead and do that. So instead of 2x, we're going to replace the x every time we see an x with a negative 4, right? So 2, negative 4 plus 7 equals negative 4 plus 3. So go ahead and work that out on both sides of the equation and see what that gets us.
You want to cover this side? I'll cover this side.
Okay.
So 2 times negative 4 would be...
So you're doing negative 4 plus 3, Kelsey, and that gets you to negative 1. Now, Darshan, you're doing 2 times negative 4 plus 7.
Plus 7. That would be negative 1.
So Darshan, you got negative 1 on your side of the equal symbol. And Kelsey, you got negative 1 on your side of the equal symbol. So negative 1 equals negative 1. Is that a true statement?
Yes.
So when x equals negative 4, and we plug it into that original equation, 2x plus 7 equals x plus 3, negative 4 for x gives us a true equation. So what you were able to do is demonstrate and explain how to find an unknown value for x when we have a value for x in an equation where we don't quite know what it is to begin with. That's one way that we can find that. Wonderful job.
There you go. Nicely done. Clear the board since you guys got that through so quickly. I'm going to give you one more.
Let's go ahead and start fresh here. All right, let's do a new page. Let's go ahead and just erase everything we've got here. All right, so let's go ahead and start with a new equation.
All right, 12x
Allow me. 12x, let's go ahead and start with our original. 12x
minus 5
minus 5.
equals 11x minus 5.
Wow. All right. 12x minus 5 equals 11x minus 5. So, Kelsey, what do you think is going to be the first thing you may want to do to start finding what the value of x would be here?
Subtract the x by x.
All right, Darshan, go ahead and work with Kelsey on what that step would look like as far as getting the x by itself.
Wait, so what are you asking for?
Okay, so you would subtract the x by the x, right?
So
How many x's are we going to subtract from that right side of the equation so that we can have it by itself on this side? So how many x's do we have on that right side of the equation? Do we have just one x?
11.
We have 11x, so we're probably going to want to take away 11x, get them all over to that side, right? So let's try that and see what happens.
minus 11x. Here, same thing, minus 11x. So here, 12x minus 11x, it would equal 1x. Minus 5 equals, these cancel out, negative 5.
This is going to be really interesting as it plays out. So now we have x minus 5 equals negative 5. How do we get x by itself on the left side of that equation? What can we add to both sides to cancel out that negative 5 that's attached to x?
So just think about the opposite of minus 5.
Is positive 5?
Positive
go.
5. So you can add 5 to both sides there.
A positive and negative cancel out, which it's x plus 0. It's x equals, this would cancel out, but it would be 0 because negative 5 plus 5, 0.
Now, before you go ahead, Kelsey, does 0 seem like a reasonable answer? She's like, I don't know. I haven't done these before. I don't know if 0 is 0 a number?
No, because it's
Well, 0 is a number, right? That's why I'm asking, because a lot of kids get confused on this. They go, 0, it can't be 0. I did something wrong. But 0 is a number, right? And you guys are going to show that that works because Darshan is going to check it and show you how to check it, all right?
So go ahead and plug that in. We have 12, and instead of x, we're going to use 0.
12 times 0 minus 5 equals 11 times 0 minus 5. So, do you want to do the whole thing now?
Well, why don't we try that, okay? Kelsey, let's start off with the left side of the equation. We have 12 times 0 minus 5. So what's 12 times 0? Let's start off with that.
0.
0, that's great. All right, so we have 0 minus 5. 0 minus 5 equals?
Negative 5.
Negative 5. Wonderful. Now let's look at the other side of the equals sign. It looks like it's going to be a lot of the same type of work here. 11 times 0 minus 5. 11 times 0 is 0 minus 5, and we know that 0 minus 5 is negative 5. So we have negative 5 equals negative 5. Both sides of the equation are the same. So x equals 0 in order for 12x minus 5 to equal 11x.
There you go. Nicely done. And just remember that 0 is a number. It can be used. You're going to get ones where fractions can be used, decimals and things like that. So nicely done. For some great work, you guys have each got yourself an ice cream courtesy of Sweet Fix. So congratulations on that. Hopefully you guys have an opportunity to go to Sweet Fix and check out one of your favorite flavors or try something brand spanking new. We'll be back with more right after this. And welcome back. We've got Darshan and Kelsey in studio with us right now. And we're going to celebrate Mardi Gras a little bit today because that's our math in the news. It is Mardi Gras Day today, Fat Tuesday. So a lot of the colors that we were talking about and what they represent are here in front of us, but they've also got some other colors and everything's pretty glittery and stuff like that. So we're going to start decorating a little bit, all right? So we've got a mask for you, Kelsey. Have you ever worn a mask like that?
No.
A big day for you right there, right? And Darshan, what about a hat like that? Have you ever had a hat like that to
I mean, I think
wear and style around town?
not necessarily.
All right, so here's what we're going to do. You know what these are? Have you ever seen these before?
They're like
Pipe cleaner?
Pipe cleaners, right? So why don't you each grab one? All right, and here we've got our do the math letters on there. All right, so what you guys are going to do is you're going to take your do the math letters and you're going to put those on your pipe cleaner. So you guys can go ahead and start putting those on. So just do it in order, right, with the D first. Now remember, if you put the D on at the far right, you're going to have to start putting the others on the far left, right, so that they go in order. So when you're looking at it, it'll say do the math instead of hatam. Okay?
Oh.
There you go.
Oh no.
All right, so keep on working on that. So as you're working on that, you guys can take a look around at some of the other objects that we've got. We've got some feathers, some of these little fuzzies, things like that. Look like some coins and things. And you can kind of think about how you would like to decorate the other hat, mask that you've got. And I think with yours, like you got a mask and maybe you could put a little top hat on there at the same time, huh? That'd be pretty slick. Maybe the old man will put on one of those too, you don't know. But you know what, while you guys are doing that, there you go. So maybe you can separate the do and the math and stuff like that. So they're just separated a little bit. And I'm gonna go ahead and get started on one of these.
I think my H is an I now.
Oh, you know what? I think some of the ink came off. So I bet you on the other side,
Oh yeah.
it might show that. And then you can kind of see that a little bit easier once it flips around. But you know what it says, right?
Yeah.
All right. So, Kelsey, as we were doing that last problem with the equations, you've never seen anything like that before, had you?
No.
And I know that we only did 2 of them, and it was kind of quick. But did you understand a little bit about how Darshan was saying that you have to keep it balanced, right? And whatever you do to one side, do to the other side. That's going to be a key when you start doing those because, I mean, it all depends upon the pace of your class. But you will do those in 6th grade, all right? And Darshan, I know you're doing those in 6th grade. Do you know when you're going to be doing those again?
Like forever.
Yeah, because it's not only going to be 6th grade, right?
Yeah.
You're going to do them in 7th grade.
Then 8th.
And you're going to do them in 8th grade. And you're going to do them in high school, right? All right, so good. So you guys have your do the math on there at the same time. Nicely done. So what you can do is, Darshan, I think what you might want to do is maybe get another pipe cleaner and kind of twist them together at the ends on both sides. Does that make sense?
So like.
Kind of get your 2 and kind of intertwine them like that.
Oh, so like it would kind of make like that, but with another one.
Right. You kind of do that. So do one on one end. Yeah, leave that one over on that end. And you're going to get another one for this end. So you're going to make a big circle. Does that make sense? So that one's going to go off to that side. And now you're going to do one over here. And let's see if we're going to be able to fit yours on your mask somehow like this. So why don't you hold that side, Kelsey, and I'll hold this side. And let's see if we can do something like this. If we take it and maybe turn it around like this. See if we can do that. If we can loop it kind of like this. Does that make sense?
Yeah.
Yeah. So see if you can get yours looped around like that and kind of make it tight so that, there you go, perfect. There you go. And I think that's on there pretty well. All right. So if you want to, why don't you get a top hat and whatever you'd like to put on it, let me know and I'll put some super glue on there for you. I just started putting a couple of fuzzies on mine right here. So Darshan, once you get yours, see if you can get yours looped around on here so that to do the math is in the front, and then just kind of tie it up at the back. Sound good? All right. What do you like there? Feathers, little fuzzy balls? What do you like? Grab whatever you like. I'll start putting some glue on it for you there.
Cotton balls.
All right, so here, I'll put some glue on each
think
of these. Just watch where it is so you can,
Thank you.
there you go.
I think I did
Put some on here. So do you guys, when you have celebrations with your family, do you guys often decorate a lot of times?
I guess.
Well, sometimes like birthdays and things like that, maybe?
Like New Year's.
Yeah, like New Year's, right? This would be awfully nice stuff for New Year's also, right?
Yeah.
And then people would be like, hey, where'd you get that stuff for New Year's? We don't see any stuff like that. And you're like, well, you got to be on Do the Math to get stuff like that, right?
Yeah.
All right. So let's see if we can get Darshan's on here real quick. Is that one tied on there?
I think I kind of did it wrong.
You guys are being
Yeah.
put together there? There we go. So we'll kind of get it like that.
Maybe
And we'll tie this around here like this.
mass.
As I know Sophia and Mac are going to want a snapshot of this because this is going to be quite outstanding when we're done with this. So what we're going to do, I know we didn't have a lot of time to put a lot of stuff on there, but we did the most important thing. So how about if you put on your hat, you want to put your mask up there? And if you can, see if you can put it on. If it, you loop it around your head there.
Kind of big.
There you go. I'll put mine on there right there. And not too bad, huh? You guys, we in the Mardi Gras mood now? There you go. There's our Do the Math, the little Mardi Gras for today. And we tied a little bit of math into everything right there. So you know what? We'll be back with more right after this.
What are cells? They are the building blocks of life. A cell is like a tiny factory that keeps living things alive. Every living thing, plants, animals, and people, is made up of cells. Some creatures are made of just one cell, but humans are made of trillions of them. Cells make energy from the food we eat and the oxygen we breathe to create the power your body needs to run, jump, and play. They are also in charge of helping you grow. They divide to make new cells, so your body can get bigger and stronger. Did you know cells are like little doctors? When you get a cut or scrape, your cells rush to the rescue to repair the damage and make you good as new. Some cells are like bodyguards, protecting you from germs and keeping you from getting sick. Let's learn about the different parts of a cell. First is the cell membrane. It's like a flexible fence that holds the cell together and has gates that allow some things in but blocks other things out. Inside the cell, there's a squishy, jelly-like substance called cytoplasm. It holds all the cell's parts, or organelles, in place and helps them do their jobs. Here's the nucleus. It's like the brain, telling the cell what to do. The nucleus holds DNA, which is like a special instruction manual for the whole body. Now let's check out the mitochondria. They are the power plants of a cell and provide energy for a cell to move, divide, and do all the things it needs to do to function properly. Next comes the ribosomes. Those are the small dots that float around in the cytoplasm. They're like little robots, quickly assembling proteins that the cell needs to grow and repair. This is the endoplasmic reticulum, or ER for short. There are two types: rough ER, which is covered in ribosomes, and smooth ER, which isn't. The ER helps make and move proteins and other materials around the cell, like a big map of roads. This next part has a funny name, the Golgi apparatus. They look like stacks of pancakes with tiny bubbles coming off them. It's like the cell's post office. It packages and ships proteins to where they're needed within the cell. These are lysosomes, the cell's clean-up crew. They break down waste and recycle old cell parts. cells have an important job. They work together like a team to make sure our bodies can move, grow, and stay healthy. Every part of you, from the top of your head to the bottom of your toes, is made of hard-working cells.
All right, welcome back. Do you guys have fun with that?
Yeah.
Yes.
That's pretty good right there, huh? So you know what? On Do the Math, there's a lot of times that you can do mathematics and play at the same time. And a lot of people think, how are you going to play and have mathematics at the same time? It happens all the time, right? So a lot of times you look for patterns in mathematics, right? And the way that you can find patterns and the easier it becomes, the more complex you're going to be presented with problems to see how high you can go in mathematics, all right? But you can also logically think and mathematically reason your way through solving problems also, okay? And sometimes there are games that seem innocent enough, but at the same time, you're actually exercising your math skills, let's say, all right? So have you guys played tic-tac-toe before?
Yeah.
Yes.
All right. Have you ever played tic-tac-toe that looks like that over there?
No.
All right, so head on over to the board. So, Kelsey, would you like to be blue or red?
Red.
Okay, so you are the red tokens, all right? The red, you'll be able to touch them and move them, all right? Darshan, you are the blue tokens, all right? So you will each take a turn as normal. You want to get 3 in a row, okay? Some of them might stay where they're at, or you can move them back and forth, right? You cannot move any of them diagonally, okay? So you can move them up and down or across, but you cannot move anything diagonally. But you could win diagonally, all right? So you could win horizontally, vertically, or diagonally, but you cannot move any piece diagonally. Have we got the rules? All right. So, Devin, you're going to be the referee. Let the game
Right down the
begin.
middle. Let's go, Kelsey. Make your first move. You can move any of the reds forwards or backwards. You can't really move them side by side yet. Okay. Darshan, it is your move.
Can you go 2 or no?
You can only go 1. Okay. Moving a little closer. Kelsey, it's your go. Okay. Darshan considering the move. Is he going to take the one that's already out, or is he going to move a new one?
So at this point, right, you guys should be thinking about a couple of moves ahead.
And not just yours, but theirs. So think about the moves that you don't want to make. Just for example, I'm going to try to, because it's our first time around, highlight the fact that, Darshan, if you move this blue one,
Then she can move
she's
that.
going to move over there. So yeah, you're thinking exactly the right way. Think about the moves that you can make and the moves that you should not make. Go ahead and keep working through some thoughts here. And you do have some flexibility. You can start to move side by side as well as back and forth now. Okay. Excellent. Kelsey, it's your go. I think you had a plan. Let's see if that's changing now. Okay. So that's an interesting move for a block. That opens it up for Darshan now to make his move. Back down between those 2 reds in the second row. Okay, now Kelsey's starting to think about some moves that maybe she doesn't want to make or open things up. The block there to keep from that blue piece maybe from coming across. Darshan back in control, and that's the win.
There you go.
So
All right,
that move opened up a block up top, but then it opened him up to slide to the right and pick up the victory.
All right, set him up again. We're going to do 2 out of 3.
All right, back to the blues and the reds, alternate through. Now, Kelsey, I believe it's still your go to go first. Different
Well, hold on a
approaches.
second now. Did Kelsey go first last time?
She did.
Do you
we play?
want to go first? Because sometimes you don't have to. If you want to go first, you can. But if you're like, I don't want to go first again, all right, there you go. We'll let her pass on this.
Sean, you can start things off. And it'll be interesting to see if there's a pattern that develops based on who goes first over time.
Oh, I see. Okay.
All right. So similar plays almost mirrored to kick things off on this playthrough. Now you do have some flexibility as far as across or back and forth now. We're going to bring down 1. Okay, so now, Kelsey, there's almost a situation where there's only one move you can make, right? He doesn't really give you a lot of choices here. Okay. And sometimes that's a part of the strategy. Force opponents into moves that they can't make. And again, it's the same situation here, right? Now, as this plays out, by being forced into certain moves, that may open you up to moves that you can make to take advantage of the situation. What's interesting right now is as we get further into the game, there's a lot more thought time in place here. All right, back up there. Now again, Kelsey, there's some moves that you can't make right now because that would open things up. So what could you do that moves some things around and give you at least some opportunity here? Because I think I see your thought process. There's two that you absolutely can't move.
Right.
But there's two that you can. So you're going to bring that down. Okay. Now, Darshan, you're in a strong position, but you're forced to make a move right now. And that's going to bring Kelsey into a spot where she might be able to turn things around here. You still have one move you can't make, but now there's more moves that you could. Okay. Darshan goes in for the block. What could we do here? There's a lot of opportunities, a lot of possibilities. And that brings it over for 3. So that blue dot was kind of hiding in that upper right corner, and I think you were waiting for the right time to bring that over there. But that was the moment, and that gives you 2 victories in a row.
All right, there you go, 2 out of 3. So nicely done. So this is a new game maybe you can play with your friends or something, right? You don't need to have red and blue circles or whatever. You can just play with different objects.
You can just have like a checkerboard.
It could be a checkerboard,
Right.
and you only use 1/4 of it.
Yeah, you can just draw it out, do whatever you guys like. So before we get moving on too far, I told you guys that you each had an ice cream courtesy of our friends at Sweet Fix. Do you guys have a favorite flavor of ice cream already?
Well, I have like a pool of favorite flavors.
All right, so what are some of them?
Let's see, like chocolate, vanilla, pistachio.
Pistachio, underrated, winner.
All right, Kelsey,
Love
what
it.
about yours?
Probably mint.
Mint.
Mint chip is what?
Mint chip, yeah.
Okay, yeah. So at Sweet Fix, they have all of those flavors, and they've got probably about 80 more. But they're all different flavors that you probably haven't had yet. And that's the beautiful thing about it, is that every month they change out a bunch of flavors, and then they keep some of the old ones also. So hopefully you guys get an opportunity. And if you go, wear your Do the Math shirt, because they love kids that run Do the Math, all right? Sound good? Sounds good. All right. We'll be back with more right after this.
Hi! This is a video about how to make sugar cookies that look like the sun. First, you mix a 1/4 cup of softened butter with a 1/4 cup of sugar. The butter should be soft so it will mix well. It was hard to keep everything in the bowl. Once it's mixed into sugary lumps, you can add 1 egg, 1/2 teaspoon of vanilla extract, and then mix it again. I had to keep pushing it down the sides of the bowl with the spatula. Next, you add 1 1/4 cups of flour and 1 teaspoon of baking powder, and then mix it again. It took a long time to push the mix into a ball. I started with a spoon and then used my hands. Finally, it felt like dough. Spread some flour on a pastry cloth or on the counter if you don't have one. And then get some flour on both sides of the dough and flatten it a little. Roll it out flat, go in both directions and stop when it's about as thick as a pencil. Then cut it out into some shapes. We tried 2 different ones. You can even use an empty jar to make circles. Put them on a metal pan covered with parchment paper if you have it. Bake them in the oven at 375 degrees Fahrenheit for 10 to 12 minutes. You should have an adult do this part. Carefully take them off the pan and let them cool for a little while as you're making the icing. Add milk slowly to 1 1/2 cups of powdered sugar. Keep adding and mixing until it starts to feel a little runny. It goes fast at the end, so be careful. Divide into 2 bowls. To make yellow frosting, add 3 drops of yellow food coloring. To make orange, use 2 drops of yellow and 1 drop of red. Spread the yellow on first. Then drizzle the orange in a neat pattern. It doesn't have to be perfect. Then you can use a toothpick to mix the orange in and make it look like the sun. Be creative! To make sunspots, we use chocolate chips and cake writing gel. They are dark areas that are cooler than what's around them. When the sun is active, it has more. Sometimes the sun is quiet and doesn't have any, so we left a few cookies plain. That's it! You're done! Except for the best part. Make sure to help clean up. Want to know more about the sun? Go here to get some great info.
And welcome back. We've got Kelsey and Darshan in studio doing a lot of math today, having some fun at it, right?
Yeah.
All right, so why don't you guys head on over to the board, because Kelsey, in your classroom, you're working with coordinate planes. So explain to Darshan what you're doing, parts of a coordinate plane, and some of the activities that you're doing with it.
All right, well, in class, we usually have a graph or a table to show us what our numbers are going to be. Like, we'll say there is an example of this would be, we'll draw a table, and this would be where our numbers are. So let's say the example is someone's putting new windows in their house, right? So this would be how many days, and this would be how many windows, right? So let's say there's 3 days, and so 1, 2, 3, and there was 20 windows put in on the first day. There was 40 by the second day and 60 by the third day. So then we'd label our grid, and we'd say, so this is going to be our y-axis, and this is going to be our x-axis. So the days will be down here, and we'll number it. This will be 1, 2, 3.
Now, one thing I think you're starting to see with this grid is the scale of this might be too big to fit on this, which is okay. We can label so that it is workable. So we can create a little bit of space here, right? Going 1, 2, 3 with a couple of squares each, or maybe even 5 squares each, might be a helpful strategy. So maybe we can go by 5s here. 1, 2, 3, 4, 5. We have 1 day. 1, 2, 3, 4, 5. We have 2 days. 1, 2, 3, 4, 5. We have 3 days. So it spaces out the scale. Now, if we go 1 piece each, we're going to get to 20 up here, but then we may run out of room going up higher to do the other points. So maybe we can say that every 5 of these will equal 20 perhaps, right? So we can say this is 1, 2, 3, 4, 5, and this is 20. 1, 2, 3, 4,
How about you
5.
make them 10?
Yeah, let's go 10. We have room.
So that way each
here.
one
Right.
counts as 2.
And what Mike mentioned is really impactful. Each of these is not going to represent 1 anymore. Each of these is going to skip counts up by 2. So 1, 2, 3, 4, 5. This is going to be 30. 1, 2, 3, 4, 5, 40. And we'll keep going. We may run out of room to get to 60, but we'll try to see what we can get to right up 1, 2, 3, 4, 5 right here. This will be 60. All right? So sometimes if we realize the scale is not going to allow us to graph a lot of these points, we may have to change the scaling on this, so which we had to do with the x-axis for the 1s and for the y-axis to get to 20, 40, and 60. So Kelsey, go ahead and continue.
Okay, so then we look and we think, oh, well, we need our ordered pairs. And so I know that our x-axis always comes first in an ordered pair. So that's going to be 1 here. And then our y-axis will be 20. So there's 1 coordinate. Then our next one will be 2, 40. And then our final one will be 3, 60.
Now, importantly enough, we want to recognize what each of those coordinates represents. So if we don't know what x is and we don't know what y is, how would we label that coordinate? so that we know what each value represents on the coordinate grid. So our standard coordinate would be, what, parentheses, x comma y? Let's go ahead and just put that there as a reference for those that are just starting to learn about the process of graphing. Okay, so let's take those coordinates and show how we would graph them on a coordinate grid.
Okay, well, my teacher always says that you have to go into the store first. You have to go up until you have to go up the elevator. So first we have to go into the store and start at 1, and then we have to go up the elevator to 20. And so following this line all the way up to 20, there would be our dot.
So I appreciate that mnemonic, that helpful way to remember. You have to go across on the x-axis first and then go up on the y. We call this a coordinate plane all the time. And I think about a plane in that same mindset. When you're sitting on a plane, if you've ever been on a plane, how does it reach elevation? How does it fly? Does it go straight up into the air first and then up and over?
No.
Not quite. It's got to take off on a runway first. So it goes across and then up. That's one way that I know a lot of students remember that as far as that mnemonic. So if you've ever been on an airplane before, that's one way to keep that in mind. So you go across and then up. So let's continue to do that same process with our other 2 points.
Okay, so we have this ordered pair. These are called ordered pairs. Our coordinates in the parentheses. Then we're at 240. First you go into the store to 2, go up the line all the way up the elevator to 40, which would be right here. So that'd be 240. And then our last one, which is 360, our ordered pair, we go in, and we go at 3, go all the way up to follow the line all the way up the elevator to 60, which is right here.
Now, ideally, we should be able to use this system to predict what y would equal if we know what x is. But what's also really interesting is that if this is a pretty standard pattern and repetition, we can actually connect all of these points and they should make a straight line. Now there's one more point that we could graph. After 0 days, how many windows would we have installed?
0.
So is that another point that we could have graphed?
Yeah, this is
Right there at that starting point. Do we know what we call that point 0, 0?
origin.
The origin. So any point 0, 0 on a coordinate grid is called the origin. We can start at the origin and connect all the points you've plotted, and if it's accurate, even with the scaling, it should make a straight line. Let's see about that.
All right, so here's our 0, 0, which is our origin, and then starting here, well, that's pretty straight, right?
Well, we can actually go ahead and draw a line to connect all those. Now, is that going to go on, is that going to stop at a certain point, or is that going to keep going on forever?
Well, it wouldn't go on forever because it wouldn't be working.
Well, if you need to install a certain number of windows.
Yeah.
Right? There's no building where you're going to continue to install 20 windows a day in perpetuity forever until the end of time.
But it could.
Theoretically, if somebody's got enough money to pay for this install job, it could happen. But right now, it may have an endpoint depending on how many days long. Theoretically, though, this could continue on forever. So if you ever see an arrow in those lines, that's to communicate this will continue on forever. And we could figure out, based on this point set, how many certain windows will be installed after a certain amount of days. And we could actually create an equation to represent that. So, after a certain number of days, what happens to x for us to get to y?
X increase.
So by how much?
1 by 1.
Well, if x increases by 1, what is happening to y? How do I get from 1 to 20, for example?
You times it by 20.
We can multiply it by 20. So 20 times x is going to get us to y. So the number of days multiplied by 20 tells us how many windows have been installed. You can take this line, and when you start working with things like graphing calculators, when you input that in, you'll get this exact same line, and it'll tell you the exact same information. Wonderful work there. Nicely done, Kelsey.
Yeah, nicely done. So one thing I'd like you guys to do is real quick. Let's say they got caught in some bad weather. It started raining, so they only worked a day and a half. So after a day and a half, can we figure out how many windows there would have been?
Yes.
What would you do there?
Well,
I would. Okay, so anything. Maybe I would just go. So 20 times 1.5 equals the y, I could go,
And we want to know what that y is,
yes,
right? How many windows would that be?
So do 20 times 1.5, right?
which is
Now, if you're looking for a quick way to do it, if you already have the line on the graph,
30.
it's going to be 30. And one quick way to show that, let's start at 1.5 and then take that elevator up and see where it interacts. Now, ideally, if this is a straight line, it should be right there where the line intersects at 30.
There you go, nicely done. So you can do it with the equation and with that coordinate plane. Also, come on over here, you guys. You guys did some fabulous work today. Did you guys know that you are now ambassadors for Do the Math?
Oh.
You know what that means?
Like you go around just, I don't know too much. It's like you go around saying something.
A lot of going around.
Promote the item?
Right,
Yeah,
you promote the item, right? So you're an ambassador for Do the Math, so you're going to promote Do the Math. So you're going to tell people about Do the Math, right? Because we gave you a uniform, your shirt, right? And when you wear that, people are going to go, hey, that's a pretty slick looking shirt you got right there. What's up with that Do the Math thing? And you can tell them all about Do the Math. All right? Sound good? We got a deal? We're going to shake on it? Shake on it? All right. Also, you guys know how to solve this? Are you guys both good at this?
Yes.
You are? No? All right. So you're going to have to explain to Kelsey, maybe show her a little bit about this. But this is an exclusive Do the Math Rubik's Cube. I bet you don't have one of those, do you?
No.
No. Now, you see, the only way you can get one of those is by being a guest on the show. And you guys were both of our exclusive guests on the show today. So we want to say thank you for coming in. Did you guys both learn a little something today?
Yes.
Good. Did you have fun doing it today?
Of course.
That's the most important thing right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.